This lecture we try to understand how to draw the state diagram of a given convolutional encoder. The question is, below figure depicts half rate constraint length 1 convolutional encoder. Sketch the state diagram. Also find the encoder output for the input to data stream 11101. Okay, rate half means one input bit produces two encoded output bits. 1/3 means for each one input bit, 3 encoded output bits are produced. So 2/3 means group of 2 input bits produces 3 output bits. Okay, in general, code rate is given as k/n. So here k is the number of input bits we process at a time, and n is the number of output bits produced for each k number of bits. So see here, this is the shift register, and the MSG represents the place for current message bit. This M1 represents state of the encoder. Because it is L is equal to 1, this is MSG message bit, and this is the state of the convolutional encoder with constraint length 1. Here state is represented by 1 bit only, so 2/2 is equal to 2 states are available. 2 states means maybe 0 state on 1 state, state 1 will be available. Suppose if 2 bits are used for state, we have 4 states. If 3 bits are used, we have 8 states. If 4 bits are used, we have 16 states are possible. Let us understand how to prepare a state table for a given convolutional encoder. Initially, the given the encoder is at all 0 state, 0 state. Initially, it will be in 0 state. So state of the encoder is represented as M1, and initial state. Initially, it is in all 0 state. And see, the state of the encoder depends on the incoming message bit. Whether the incoming bit is 0 or whether the incoming bit is 1. So the change of state depends on the incoming message bit. So see here, for initial state 0, let us assume 0 state. If the incoming bit is 0, it is in the 0 state. If the incoming bit is 1, 0 state, initial state. Because 0 and 1, because it is a binary convolutional encoder, we have only 2 possibilities. The incoming bit may be 0 or may be 1. Again, initial state, we assume 1 for incoming bit to 0 and 1. So state 0 is represented with letter A. Letters A represent bit 1 represent state B. State 1 is represented with letter B. So initial state may be AA, BB, something like this. If 2 bits are used for the state representation, in the case of constraint length 2, we can have 4 states, and we assume 0 represent A, 1 represent B, 10 represent C, and 11 represent D. But in our example, only 2 states are available, either state A or state B. First, we try to find encoded output of the encoded output of the convolutional encoder, given convolutional encoder. From this diagram, we can say x1 is equal to MSG. This is MSG, and this is M1, and x2 second output MSG, exclusive OR of MSG plus M1. So this is the output to 2 and output to 1. So here we can find directly x1 x2. The output, final output will be represented with x1 x2 x1 x2 x1 x2 like that. So if you find, suppose if MSG is 0, we get x1 is equal to 0, x1 is equal to 0 we get. This is x1 x2. If x2 will be m1 is 0 and MSG is 0, we will get 0 plus 0. This will be 0 0. So the output of the encoder will be 0 0. Similarly, we can find output of the encoder using these equations. Here this symbol represents XOR logic or modulo 2 addition. Let us calculate the next states of a given convolutional encoder. The state of the encoder changes only after applying the clock pulse. If you apply clock pulse, then only the state of the encoder or shift register will get changed. Suppose the encoder may be at 0 state or 1 state, depending on the initially at 0 state or 1 state, depending on the incoming message bit. In step 1, suppose let us assume it is at 0, the state of the shift register or the state of the encoder is 0, and if this red bit, the bit color in red represents incoming bit, if the incoming bit is 0 and the state of the shift register is initially at 0, after applying the clock pulse, this 0 goes out, it will be discarded. This 0 comes to, sorry, this, okay, after right shift by 1 bit, this 0 will be discarded and this will come to M1, MSG will come to M1 after applying 1 clock pulse, right shift by 1 bit. So the state of the encoder changes from 0 to 0. So that is why 0 represents A. The state changes from current state, present state A to next state A. And in the second step, we assume initial state is 0 and we assume the incoming bit is 1. The incoming bit is 1. So these are the contents of the shift register. Then the state will change after applying the clock. So this 0 will be discarded and this 1 will come to M1 place. So M1 represents state of the encoder. So state of this one represents state B. So it changes from initial state 0 to state to B. State to B. If the incoming bit is 1 and initial state is 0. In step 3, we assume the state of the encoder is 1. It is at state B. It is at initial state B. And we assume the incoming bit is 0. After applying the clock pulse, this 1 gets discarded. This 0 comes to M1. So this is nothing but state A. So M1 represents state of the encoder. So if the incoming bit is 0, the state changes from state B to A. B to A. So this is the initial state and this is the final state or next state. In step 4, again we assume the encoder is at state B, that is it is at state 1, and we assume the incoming bit is 1 and we apply the clock pulse. This one's go to, it will be discarded and this one comes to here. So state changes from 1 to 1, that means B to B. State changes from B to B. So try to understand to prepare this state table, because the state table is very useful to draw state diagram, code trails diagram, tree diagrams. These diagrams are graphical representation of convolutional codes, related graphical representations. So from these graphical representations we can find output of the convolutional encoder for any given input. So this will be the present state, and after applying the clock pulse we change it to these states. So initial state is like this, and next state will be, you blindly remember, next state will be always the first column. In case of L1, L1 means constraint length 1. For constraint length 2, first two columns will be there. We will see that in next example. So the initial state is this one, and both will be same. State A, AB, AB. So this is AB, AB. We have understood how to prepare this state table, because this state table is useful to draw state diagram, trellis diagram, and also tree diagrams. See here, we will try to draw the state diagram from this state table. So we represent in some rectangular boxes the states of the convolutional encoder. We have already seen state A represents 0, state B represents 1. This is the state of the encoder. And also remember, this solid line represents bit 0. If the incoming bit is 0, we use solid line. If the incoming bit is 1, we use this dotted line. These are the convention we use to draw the state diagram, trellis diagram, or a tree diagram. Let us assume we start with all 0 state. It is at 0 state. All 0 means the state of the encoder is at 0 state, M1. M1 is at 0 state, state A. And if the incoming bit is 0, then state changes from A to A. This is called a self loop. If the incoming bit is 0, state changes from, we represent here, state changes from A to A. The output is 0, 0. We represent the output here, 0, 0. And if the incoming bit is 1, and initially at state 0, it changes from state A to B. If the incoming bit is 1, so 1 is represented with dotted line. State changes from A to B, and the output is 1, 1. And if the incoming bit is 0, and if the state of the encoder is at B, we assume if the state of the encoder is B, B means 1. If the incoming bit is 0, the state changes depending on the input bit, B to A. So as it is 1, we use again dotted line, B to A. The output of the encoder is 0, 1. Sorry, the incoming bit is 0, so we use solid line. And if we assume if the encoder is at state B, that means state B, and the incoming bit is 1. If incoming bit is 1, we have to use dotted dashed line. State changes from B to B. That means self loop. As the input is, we use dotted lines. The same thing you can see here. Solid line we use for bit 0, dotted line we use for bit 1. This diagram we draw from this state table. So In each branch we represent the output of the encoder. Other way of drawing the state diagram, if you don't want to use a dashed line, we can represent in this fashion 0/01. This 0 means incoming bit. 0/01 means input by output. For current input bit 0, the resulting output is 0/1, like that. If we represent like this, we don't have to use dash and solid line representation. Suppose we are given state diagram. We are given state diagram and we are asked to find the output of the encoder for a given message sequence. The message is given 11101. So how to find encoded output from the state diagram? State diagram, we know the state diagram. So initially we start from all 0 state. All 0 state means 0 state. In step 1, initially we are at state A, because state A is the initial state, 0 state. We check the first message bit. First message bit is 1. See here, the first message bit. This represents the input message is 1. See from node A. For bit 1, state changes from A to B. The output is 1 1. We have to find the output. Output is 1 1. State, we are changing from state A to state B. Now we are in state B. Now we are at the node B or state B. Check the second incoming message. Second incoming message is also 1. See from node B. 1 means see here. This is incoming with 0. This is incoming with 1. That means this one. The state changes from B to B. Self loop. The output is 1 0. Similarly, we can find output of the encoder for different input bits. For this message bit 1, this is the output. For this message bit, this is the output. For this message bit, this is the output. So similarly for this message bit, this is the output. So this is the input sequence, and we can find the encoder output from the state from the given state diagram. As the given convolutional encoder is 211. This is each input bit is converted to 2 output bits. Each input bit is converted to 2 output bits, because it is 2, 1. This is K and this is N. If you want PDF files of my video lectures, please visit www.engineerstutor.com. For PDF link, see description of the video. You can also write to me at rkgopal2020@gmail.com for any doubts and queries.